Yesterday we did Theorem 1 of the grade 12 work, which says if you have a triangle and in that triangle you have another parallel line to one of the sides, that means that a side is part of the parallel lines, otherwise it's also there. Then we can say that we can divide this side into proportions and the other side into proportions as well. Now what is important for today's lesson is that you should realize that one of the parallel lines is a side of the triangle. Okay. Now let's look at this example, example 3 on your notes. It says D and E are points on AB and BC in triangle ABC, so that DB equals 2 to 3, AB is 2 to 3. And BE is 4 over 3 EC. Okay, they don't tell us what EC is, so let's make it X. And they tell us that BE is 4 over 3 times EC, so it's 4 over 3 times X. They also say DK is parallel to AE and they cut at point P. Now we must determine CP, this one, to PD, that one. And it actually looks overwhelming. Do you agree? Now the first step is to identify the triangles. Now remember the tip I gave you here? One side of the parallel lines is one side of a triangle. So if this and this are parallel lines, we should look for triangles where this line and that line forms a side of a triangle. Okay, what do you think? Where is my triangle? ABE, yes. So ABE is a triangle. Where's my other triangle? DKC. That one. Good. Now we can start. We want these two in proportion. If you look at the green triangle, we know that the proportions are 2 and 3. So what will the proportions in the green triangle be on this side? I'm going to ask again. In the green triangle, if the proportions are 2, 3, what will the proportions be on this side? 2 and 3 as well. So this one will be 2 and that one will be 3. Okay, does that make sense? It's yesterday's theorem. Doesn't it make sense? If we have a triangle with parallel lines, and I say the proportion of those two are 2, 3, what will the proportions be on this side? The same, 3, 2. Yesterday's theorem. Okay, are you with me? So that's why I say this part is also 3 and that part is also 2. Okay, so now you say in triangle ABD, BK over KE will be the same as BD over DA. BK over KE will be the same as BD over DA. And both of them are 3 over 2. The reason? Line is parallel to one side of a triangle. If you look at the big triangle, the whole one, the big one, ABC, how long is AB? 5. How long is BC? 4 over 3x plus x. Okay. So further, we have that 4 over 3x equals, okay, look at the green one again. 4 over 3x will be equal to 5. Now we can solve x. We multiply with the reciprocal, 3 over 4, and then we can cancel out all the numbers, but we must also multiply here with 3 over 4, and then you get x equals 5 times 3 is 15 over 4. Why did I solve x? Because the question asks, I have to get the ratio of those two lines, or those two pieces of the yellow triangle, and x is part of that. We know that KE is 2. So we need to solve x in order to get the proportion of the other two sides, or the other side. In triangle DKC, the yellow one, CP over PD will be the same as CE over EK. Line is parallel to one side of the triangle. Okay. They asked us to get the ratio CP to PD. CP to PD. So we're on the right track. If we get an answer here as a fraction, we can just split it as a ratio. So CE is X, and we know X is 15 over 4. So substitute that. 15 over 4 over EK is 2. And if you calculate that, you'll get 15 over 8. Now just write it as a proportion. Therefore, CP to PD will be 15 to 8. So the first step, when you get a bowl of spaghetti like this, is to identify the parallel lines and then identify your triangles. Then make sure that you put in all your ratios and all the pieces that you have, and then go from what you have to what you want. Right. Parallel lines. And then, when you have your parallel lines, you identify your triangles so that one parallel line is a side length of the triangle. Then you write your proportions and you put it in everywhere where you can. Then you identify what do you want. I want those two. What do I have? I have these. So I actually need an X. I have the 2 in order to get those proportions. And then you work towards that.
When you say step 2 is what?
Step 2 is identify your triangles. So that one parallel line is a side of a triangle. Okay, let's do the second example 4. In triangle ABC and triangle ACD, XY is parallel to BC and YZ is parallel to CD. Okay, so which triangles do I have? ABC and ACD. Okay, let's identify them. There is one. With these parallel lines. And there is another one. With these parallel lines.
Yeah?
Yep.
And this is what I think actually. And how would we be able to differentiate between using the theorems and using what is this congruency?
What? How will we do?
How are we supposed to differentiate if this we should use this what you're doing now and assume this is the theorem of congruency?
Okay, grade 11's mid-theorem triangle was if you connect the midpoint of that side with the midpoint of this side, then they are parallel. Grade 12 work is I give you parallel lines, but it's not midpoints. Okay. Alright, they ask us, prove that XZ is parallel to BD. So we need to prove that one. Where do we start? I identified my parallel lines. I identified my triangles. Now you go to the proportions. Okay, let's do the blue one first. What can we say about the blue triangle? AX over XB, go down. AX over XB is equal to over YC. So we say in triangle ABC, it's just easier for yourself. You're not going to get a mark for that, but it's easier for yourself to identify with which one you're going to work now. Okay. AX over XB equals AY over YC. It's a line parallel to one side of the triangle. Now, in the other triangle, in triangle ICD, we have AY over YC equals AZ over ZD. A line is parallel to one side of the triangle. Why? Why?
Because then AY over YX is equal to AZ. I don't know why, but then you can because they the similar.
Okay. This one is equal to that one. The same one is equal to something else. Therefore, that will be equal to this. Can you see? It's the same thing. I look like my mother. My mother looks like her mother. Her mother looks like my great-great-great-grand. So I look like my great-great-great-grand. Do you follow the reasoning? Okay. Therefore, therefore, AX over XB will be equal to AZ over ZD.
No, but they have a common line.
What?
Can't you use that as a reasoning because they have a common line, they share the same line. That AY over.
Yes, they have a common line here, but you have to prove that this triangle has the same proportions as the other one. Okay, and I proved it. This one over that one equals this one over that one. But this one over that one is also the same as that one over that one. Therefore, this one over this one will be the same as that one over that one.
So then the only reason you have is because line parallel to one side of triangle.
Yes, and now you use your common sense, which says if something equals to the yellow and the yellow equals to something else, then those two must be equal.
So then you don't have to explain that because they share the same.
No, you don't have to explain. That's why I say therefore. Okay. Now you look at your triangle and you see AX over XB and AZ over ZD actually forms part of that triangle. Can you see?
Yes.
AX over XB and AZ over ZB forms part of that triangle. Now, if I say that these proportions equal those proportions, it must be that those two lines are parallel. Okay, hello. If this proportion equals that proportion, those two lines must be parallel, and that's what I wanted to prove. Therefore, XZ is parallel to BD. If you say therefore, you don't have to give a reason. Hey, jump.
So there's no reverse theorem for this.
There's no?
Reverse theorem, like
No, but you can reverse your reasoning. If these two are proportions, then those two lines must be parallel. Where's my example? Yeah.